I think through the open source model, you can do things a bit differently. We have kind of like the inspiration of open source for infrastructure and database, like with companies like Elastic, MongoDB, that have shown that you can, as a startup, empower the community in a way and create like 1,000 times more value than you would by building a proprietary tool, right?
You're listening to Gradient Descent, a show about machine learning in the real world, and I'm your host, Lucas Bewald. Clem DeLong is CEO and co-founder of Hugging Face, the maker of Hugging Face Transformers Library, which is one of the most, maybe the most exciting libraries in machine learning right now. In making this library, he's had front row seats to all the advances in NLP over the last few years, which has been truly extraordinary, and I'm super excited to learn from him about that. All right, so my first question is probably a silly question because almost anyone watching this or listening to this would know this, but what is Hugging Face?
So we started Hugging Face a bit more than 4.5 years ago because we've been obsessed with natural language processing. So the field of machine learning that applies to text. And we've been lucky to create Hugging Face transformers on GitHub that became the most popular open source NLP library that over 5,000 companies are using now to do any sort of NLP, right? From information extraction, right? You have a text, you want to extract information. So platform like Chegg, for example, for homework is using that to extract information from homeworks. And you can do text classification. So we have companies like Monzo, for example, that is using us to do customer support emails classification. They receive a customer support email. Does it like relate to which product team, for example? Is that urgent, not urgent? To many other NLP tasks like text generation for autocomplete, or really kind of like any single NLP task that you can think of. And we've been lucky to see adoption not only from companies but also from scientists, which have been using our platform to, share their models with the world, test models of other scientists. We have almost 10,000 models that have been shared and almost 1,000 data sets that have been shared on the platform to kind of like help scientists and practitioners build better NLP models and use that in their product or in their workflows.
And so Hugging Face Transformers is the library that's super well known, right? And then the platform is a place where you can go to use other people's models and publish your own models. Do I have that right?
Yeah, exactly. With like a hybrid approach to building technology, we feel like you need kind of like the extensibility of open source and practicality of, for example, user interfaces, right? So we cover really kind of like the full range, meaning that if you're a company, you can do everything yourself from our open source, not talk to us, not even go to huggingface.co, do everything from, pip install transformers, right? If you want a bit more help, you can use our hub to discover a new model, find a model that works for you, understand these models. To even in a more extreme way, if you're like a software engineer or if you're new to NLP or even new to machine learning, you can use our training and inference APIs to train and run models. And we're going to host this inference and this training for you to make it very, very simple so that you don't have to become an NLP expert to take advantage of the latest state-of-the-art NLP models.
That's so cool. I mean, I want to zoom in on Hugging Face Transformers first because it's maybe it might feels like it might be one of the most popular machine learning libraries of all time. I'm kind of curious what you attribute to that success. Like, when did you start it, and what were you thinking, and what did you learn along the way?
Yeah, I mean, it might be, I don't know if it's the biggest machine learning open source. It's definitely the fastest growing because it's fairly new. We released the first version of it 2.5 years ago, which is not a long time ago in the grand scheme of open source, right?
Yeah, for
If you
sure.
look at all the kind of like most popular open source, you see that they usually need a very long time of maturation, right? So the grand scheme of open source transformers is very much still a baby, but it grew really, really fast. It really blew up with over 42,000 GitHub stars, over a million pip installs a month. I think we have 800 contributors to transformers. And the main reason why I think it's successful is, to me, because it really bridges the gap between science and production, which is something fairly new, and that not a lot of open source and not a lot of companies manage to do. I strongly believe that machine learning, compared to, you can call it like software engineering 1.0, or software engineering, or computer science, even if computer science has science in the name of it, it's not a science driven topic, right? If you look at good software engineers, they don't really read research papers. They don't really follow the science of computer science. Machine learning is very different. It's a science driven domain, right? It all starts from a couple of dozen kick-ass kind of like NLP science teams all over the world that are creating new models like, BERT, T5, Roberta, all these new models that you've heard from. And I think what we managed to do with transformers is to, give these researchers a tool that they like, to share their models, to test models of others, to go deep into kind of like the internals of the architecture of these models, but at the same time create an easy enough abstraction so that any NLP practitioner can literally use these models just a few hours after they've been released by the researchers, right? And so we created that there's some sort of like a magic, some sort of like a network effect, or some sort of magic when you bridge the two. We don't understand all the mechanics of it yet, but yeah, there's some sort of a network effect for it. Each time there's a new model released, like the researcher is releasing it within transformers, people are hearing about it, they're talking about it, they want to use it, they test it on transformers, they put it in production, it works. So they want to support it more. The scientist is happy that his research is seen, is used, is impactful. And so they want to create more and they want to share more. So there's this kind of like virtuous cycle that I think allowed us to grow much faster than traditional open source, and that kind of like struck a chord on the market and on the field of machine learning.
Yeah, I guess as an entrepreneur, I'm always kind of fascinated by how these virtuous cycles, get started. Like when you go back 2.5 years ago, when you're just first starting the Transformers project, like what was the problem you were trying to solve, and what inspired you to even make an open source library like this?
I could probably give you kind of like a smart, thoughtful
No,
answer
I want the
to
real
this.
answer. Yeah, tell me what's actually happening.
The real truth is that we didn't think much about it. We've been using open source for a while. We've always felt like in these fields you're always standing on the shoulders of giants of other people who've built on the field before. We've been used to this culture of, when you do science, you publish a research paper, and for research in machine learning, you even want to publish open source rather than a paper, right? And so since day one at Hugging Face, we've always done a lot of things like in the open, sharing in open source, and here for transformers, it started really, really simply with BERT, that was released in TensorFlow. And Thomas, I was a co-founder and chief scientist, was like, oh, it's in TensorFlow. We need it in PyTorch, right? So I think two days after BERT was released, we open sourced PyTorch BERT. And that was like literally the first name of the repository, and it blew up. People started using it like crazy. And then a few weeks after, I don't remember what model was released. I want to say Roberta, but no, Roberta was much later. But another model was released. Maybe it was GPT, actually. I think it was the first GPT was released, and I think same thing. It was probably just in TensorFlow, and we're like, okay, let's add it. And it felt like all right, let's make it so that it's easier for people to try both, because they have different capabilities, good at different things. So we started thinking about what kind of abstraction we should build to make it easier, and very much like that, it went organically. And at some point, like researchers were like, I'm going to release a new model, can I release it within transformers? And we say, okay, yeah, just do that. And they did that, and kind of like a snowball, it became bigger and bigger, and brought us to where we are now.
That's a really cool story. I didn't realize that you were trying to port models from TensorFlow to PyTorch. I mean, now you work with both TensorFlow and PyTorch, right?
Yeah.
Do you do you feel did you feel at the time, I guess, a preference for PyTorch, or why was it important to you 2.5 years ago to move something to PyTorch?
I think the user base was different, right? So we've always been like passionate about democratization, or like making something like a bit obscure, a bit niche, making it like available to more people. We feel like that's how you get the real power of technology, is when you take something that is in the hands of just a happy few, and you make it like available for more people. So that was mainly the goal. There are like 10 people who are using TensorFlow. There are people that are using PyTorch. We wanted to make it available to people using PyTorch. We were using PyTorch ourselves extensively. We think it's like an amazing framework. So yeah, we were happy to make it more available. And what the funny thing is that as we got more and more popular, at some point we've seen the other movement, in the sense that people were saying, at some point we were actually named PyTorch Transformers, and we started having a lot of people working on TensorFlow. It was like, guys, like it's so unfair. Why can I just use transformers if I'm using PyTorch? And so that's when we extended to TensorFlow and dropped the PyTorch transformers, dropped the PyTorch in the name, and became transformers to support both. And it's been super interesting, because if you look at our integration of PyTorch and TensorFlow, it's more comprehensive. It's more complete than just having half of it that is PyTorch and half of it that is TensorFlow. You can actually kind of like on the same workflow, in a way, on your same kind of like machine learning workflow, you can do part of it in PyTorch. So for example, when you want to do more like the architecture side of it, PyTorch is really, really strong. But when you want to do kind of like serving, TensorFlow is integrated with a lot of tools that is heavily used in the industry. So in the same workflow, you can start building your model in PyTorch, and then use it in TensorFlow within the library, which we think is pretty cool, because it allows you to take advantage a little bit of the strengths and weaknesses of both frameworks.
And so, do you get a chance to use your own software anymore? Like, do you Hugging Face build applications ever at this point, or are you just making these kind of tools for other people?
Yeah, we play with them a lot. I think when our most popular demo ever was something called Write with Transformers, which was some sort of kind of like text editor powered by some of the popular models of transformers, that got, I think something over 1,000 books, the equivalent of 1,000 books have been like written with it. It's some sort of like what you have in your Gmail autocomplete, but except much more silly and creative. So it works really well when you have kind of like the syndrome of can you say that in English? Syndrome of the white page, when you don't know what to
Oh
what to
yeah,
write.
yeah. I don't
It's
think
going
we say it like that, but I
yeah.
understand the
Yeah,
experience.
in French, we say le syndrome de la feuille blanche, when you like you want to write but you don't know what to write about. It's helping you like being more creative
Uh huh.
by suggesting kind of like long, interesting text to it.
That's really cool. So I wanted to ask you. I feel like you have a really interesting lens on all the different architectures for NLP. Like, I guess, are you able to know kind of what the most popular architectures are, and have you seen change in that over the last 2.5 years?
Yeah, we do can see kind of like download kind of like volumes of models. So it's super interesting to see, especially when new models are coming up, to see if they're successful or not, how many kind of like people using something that's been super interesting to us is that actually the number one downloaded model on the hub is DistillBERT, right? So like a model that we distilled from birds. But there's also a lot of variety in terms of usage of models, especially as I felt like over the years they became in a way a bit more specialized, right? Even if they're still kind of like a general, pre-trained language models. I feel like more and more as each new model came with some sort of an optimization that made it like perform better, either on short or longer text, on generation tasks versus classification tasks, multi-language versus like mono language. You start to see more and more diversity based on what people want to do with it, and what kind of strengths and weakness do they value the most, right? A little bit like what I was talking about between PyTorch and TensorFlow. People are trying to not so much decide like which model is the best, which is kind of silly in my opinion, but which model is the best for which task, for which context, and then pick the right tool for the task.
I guess for someone listening to this who doesn't have an NLP background, could you explain what BERT is and just what it does, and maybe how Distilbert differs from that?
Yeah, so the whole kind of like revolution in NLP started with a seminal paper called "Attention is All You Need," right? Which was introducing this new architecture for NLP models based on transfer learning. And BERT was the first kind of like most popular of these new generation of models. And the way they work is in a simplistic way, without getting too technical, is that you pre-train a model on a large of text on one specific task. So for BERT, for example, it's mask filling. You give it sentences, you remove a word in middle of the sentence, for example, and then you train the model on predicting this missing word. Right. And then you do that on a very large corpus of text, usually, slice of the web,
Mhm.
right? And then you get a model, a pre-trained model that has some kind of like understanding of text, that you can then fine tune.
Mhm.
Hence, the name transfer learning, because you can go from one kind of like pre-training task to other fine tuning tasks. You can fine tune this model, for example, on classification, right?
Mhm.
By giving it like a couple of thousands of examples of a text, and classification for customer support emails that I was talking about, classification urgent and not urgent,
Mhm.
right? And after that, the model is surprisingly good at classifying a new text that you give it based on urgency, and it's going to tell you, okay, this message, there's like 90% chance it's urgent based on what I've learned in the pre-training and in the fine tuning.
And so, like for example, with BERT, I guess you have a model that can fill in missing words. How do you actually turn that into a model that say classifies customer support messages?
Yeah, with fine tuning, you fine tune kind of like adding a layer. You fine tune this model to perform on your specific task, and that's kind of like in a more kind of like a long term way. I think that's a very interesting way of doing machine learning, because intuitively you almost feel like it's the right way to do machine learning, in the sense that what we've seen in the past with machine learning, and especially for startups, a lot of them have kind of like sold this dream of doing machine learning and doing some sort of like a data network effect on machine learning, right? Because there's this assumption that you're going to give more data to the model, and it's going to perform better. And I think that's true, but the challenge has always been that you have more data, and so your model performs incrementally better, but only on what you're able to do already, right? So if you're doing, I don't know, time series prediction, maybe you have like 1 billion data points, right? And your model performs at 90% accuracy. You add like maybe 9 billion, 10 billion additional data points, and your model is going to perform at 90.5% accuracy, right? And that's great. I mean, that's good improvement. That's something you need, but it doesn't give the kind of increased performance that you're really expecting from a typical network effect, in the sense that it doesn't make your result like 100x, 10x, 100x better than without it. With transfer learning, it's a bit different, because you not only kind of like improve incrementally the accuracy on one task, you give it more ability to solve other tasks. And so you actually not only increase the accuracy, but you increase the capabilities of what your model is able to do. And so I won't go into kind of like the crazy Musk type kind of like prediction, but if you take actually Elon Musk kind of like OpenAI founding kind of like story, where he's saying like, we need to bring the whole community together to contribute to something open source for everyone. Intuitively, you could think that could come with actually transfer learning, in the sense that you could envision a world where every single company is contributing with their data sets, with their compute, with their weights, the machine learning model weights, to build these giant kind of like open source models that would be able to do 100x more things than what each of these companies could do alone. I don't know if we're gonna get there in the foreseeable future, but I feel like that's, in terms of concepts, that's something interesting to look at when you think about transfer learning, as opposed to the other techniques of machine learning.
I guess, did you have a feeling about OpenAI not releasing the weights for the early GPT models, or I guess any of the GPT models?
Yeah, so GPT-2, I think that they had a couple of version in between, were open source, right? And it's in Transformers, and we have a lot of companies using them. There are probably more companies using like GPT-2 through Transformers than GPT-3 today. They're a private company, so I totally respect their strategy not to open source a model that they built. I think they've done an amazing job with GPT-3. It's a great model for everything. When you want to do text generation, it's really useful. I'm really thankful for all the work they've done democratizing the capabilities of NLP. As our goal is to democratize NLP, I feel like what they've done promoting it into more like of the startup community, in a way. A lot of people realized with their communication that you could do so much more than what we've been doing so far with NLP, which is great. I think it participated to the development of the ecosystem, and putting kind of like NLP in the kind of like spotlights, which has been really great. And we see a lot of companies like starting to use GPT-3, and then obviously it's expensive, it's not really extensible, you can't really like update it for your own use case, and it's hard to build some sort of technological competitive advantage when you build on top of an API, proprietary API from someone else. So we see a lot of companies, using GPT-3 and then discover NLP, and then coming to our tools. And the same way happens, I'm sure it's the other way around. Some people start with our tools, our open source, and then they decide to kind of like use something a bit more off the shelf, like GPT-3, or like Google NLP services, or AWS Comprehend. Providing an API for NLP has been around from these companies too. So I think everyone is part of the same ecosystem that is growing. So that's super exciting.
Do you feel like there's a difference in the GPT approach versus the BERT approach that you were talking about? I mean, GPT has been very high profile and the text generation is really impressive. Do you feel like OpenAI is doing something kind of fundamentally different there?
Yeah, so they are both, transformer models, right? They kind of like same technique with slightly different architectures, right? So for example, when BERT is doing mask filling, GPT is doing language modeling, so next word
Mhm.
prediction. So it's a bit different. That's why the text generation capabilities are so much stronger. It has its limitations too. Like for example, if you want to do classification, you shouldn't do it with GPT. Like it doesn't make sense at all. So yeah, they solve different use cases with kind of like slight variations of the architecture. We've had people studied reproducing GPT. I mean, we've had GPT-2. We've and a team called Elusur. I don't really know how to pronounce it, but released GPT Neo a few days ago, which is the same architecture as GPT-3, just with less weights for the moment, but they intend to kind of like grow the weights. I think the size of their model is the equivalent of the smaller GPT-3 that OpenAI is providing through an API today, and it works well. It's interesting, to see the power of the open source community. I think one of my fundamental conviction is that on a field like NLP or machine learning in general, the worst position to be in is to compete with the whole science and open source field.
Sure.
Just because I've been in this position before. Actually, the first startup I worked for, we were doing machine learning for computer vision.
Uh-huh.
Back in Paris, French, obviously, as you can hear from my accent. But so competing against the science field and the open source field on such a fast moving topic is a difficult position to be in, because I
Mhm.
think you have hundreds of research labs at larger organizations or like at universities that are not so much kind of like potentially each one better than what you can do at the startup, but just there are so many of them that when you can do just one iteration, you have hundreds of like out there doing one iteration too. So like you can outpace them and like beat the state of the art for a few days, but then someone who started just a few days after you is catching up, and then you're not kind of like ahead anymore. So yeah, we've taken a very very different approach by, instead of trying to compete, I think, with open source and with the science field, we're trying more to empower it in a way. And I think through the open source model, you can do things a bit differently. We've kind of like the inspiration of open source for infrastructure and database, like with companies like Elastic, MongoDB, that have shown that you can, as a startup, empower the community in a way and create like 1,000 times more value than you would by building a proprietary tool,
Mhm.
right? And that you don't have to capture 100% of the value that you create, right? That you can be okay creating like an immense value and just capturing one% of it to monetize, to make your company sustainable, and that can still kind of like make a large public company, like in the case of MongoDB, for that both has kind of like this open source core, but at the same time can grow an organization and be sustainable. And I don't see why it should be different for machine learning. We haven't seen a lot of large open source machine learning companies yet. For me, it's more a matter of how early the technology is. It's too early to have large open source machine learning companies, because I mean, 5 years ago, nobody was using machine learning, but it's gonna come. I think I wouldn't be surprised in 5-10 years, you'd have kind of like a 1, 2, 3, 4, 5, 10 massive open source machine learning companies.
I guess you've had really front row seats to like the cutting edge of NLP over the last couple of years. Do you feel like the applications have changed with these models getting more powerful and useful? Like, are there things you see people doing now that you wouldn't have seen people doing 3 years ago?
Yeah, honestly, I think out of the 5,000 companies that are using transformers, I mean, the vast majority of it, I mean, it's hard to tell, but we see a lot of them that are using transformers in production, and I would say that most of them weren't using NLP in production, 5 years ago,
Hmm.
right? So a lot of these are new use cases that either weren't possible before, so the companies were just not doing it, or really were performed by humans,
Mm-hmm.
right? Moderation, for example, is a good example of that. Customer support classification, as I was saying, it's replacing kind of like a very manual process. Autocomplete, is really big in Gmail. It's been like my biggest productivity enhancement. I feel like in the past few months is using Gmail autocomplete to basically write just half of my emails. Now most of the search engine are mostly powered by NLP and by transformer models. Google now is saying that most of their queries are powered by transformers. So arguably it's like the most popular consumer product out there. So yeah, I think it's changing like so many products, the way products are built. I'm really interesting, and that's why also like seeing GPT-3 kind of like promoting NLP into the startup world is super interesting, because I think it's very game changer when you have companies starting building products from scratch leveraging NLP,
Right.
because I think you build like differently, right? When you start kind of like building a legal, you can think of basically every company today, and it's really fun to think, what if these companies started today with today's NLP capabilities?
Mm-hmm.
And you see that, yeah, you have so many ideas for them to do things differently. And you take like DocuSign, right? What if DocuSign with kind of like analysis of documents started today with NLP? You think Twitter,
Wait.
what
Tell me
if
about DocuSign, because what I do with DocuSign is I get like a message and then I click sign and then I sign the thing. So, what would be different about DocuSign if it was started with like all the technology available today?
I don't know. It would give you like so much like analysis of there would be a too long didn't read
For the
first,
contract.
first for the contract,
Uh-huh.
like so instead of having to read, five different pages, five page long like a document, you would have like an automatically generated summary
Uh-huh.
of the document.
I see.
It
I see.
would highlight in green or red the interesting part in the documents.
Mhm.
Like when you see, oh, there's a big kind of like money shot. That's where they define how much money you're gonna make.
Yeah. Right.
Big green flashing lights. Be careful about, or when there's a small like a small star that says everything that we wrote before is completely not kind of like, it doesn't work in that case, like the small kind of like conditions. You would put
Uh-huh.
like a big red flashing light. Be careful, here is they're trying to screw you here.
I love it.
Things like that. Things
Okay.
like
Okay.
that.
That was so fun. What? All right. Tell me about Twitter started with this technology available.
So what could Twitter do? So first it would do the feed completely different, right? It would not show you tweets because they're popular, or tweets because they're I mean, not popular, I would say controversial, but it would show you tweets that you would relate to,
Mm,
tweets that you would be interested in, based on what you um, tweeted before.
mhm.
um, Hopefully it will be able to moderate things a bit better, avoid more biases, avoid more kind of like violence, inappropriate racism, and kind of like bad kind of like behaviors like that. What else could it be? Would have wanted obviously an edit button, but I don't know if NLP would help with that.
Oh, what button?
No, and like like this like famous thing that for kind of like ages everyone has been asking for like a edit button
Oh,
on the
edit
tool,
button. Oh, yeah, yeah, right, right.
but it wouldn't be NLP powered. But still, if they started today, I would add that. What else? Do you have any idea of what they would do differently with NLP today?
Well,
What you get?
honestly, I don't know how you feel about this, but when I look at the text generation technology, the NLP technology, I mean, that was the field I actually started in, 15 years ago or more. And I almost feel like the thing that's intriguing is the lack of applications for how amazing the technology seems to me. Like, I feel like, I remember the Turing test was this thing of like, if you could, converse with a, I forget exactly the framing, but it's like converse with a computer for like 10 minutes and you can't tell if it's a human, maybe we have like AGI at that point. And it seems like that seems so impossible. And now it seems like, we're going to seems like we'll pass it sometime soon. I mean, there's variants of it, but I feel more and more like it's probably computers could trick me into thinking that I'm talking to a person, with just GPT-3 or another text generation model. But I actually feel like I don't engage with totally new NLP applications yet, and I kind of wonder why that is.
Yeah, I mean, I wouldn't agree with you. I think the usage of it is really like everywhere right
Hmm.
now. I mean, yeah, there are not a lot of products that don't start to use some NLP, right?
Maybe it's just more
It's
subtle than I would.
yeah, yeah, maybe it's less in your face in the sense that it hasn't been these big kind of like conversational AI interfaces that took over in a way, right? For a very long time, it was kind of like almost a popular and kind of like mainstream face in a way of NLP, right? People think NLP for Siri, Alexa in a
Right.
way, and that's true that we haven't seen that picking up, right? Chatbots haven't proved to be very very good yet, and we're not there yet in the capabilities in really kind of like solving real problems.
Hmm.
But I think it's became adopted in a way more slow way, in a way more kind of like incremental way compared to the existing use cases. You're probably using Google every day, and that's true that maybe you don't see much of the difference between the search results before and now.
Hmm.
But the reality is that it's the most mainstream, most used product of all time that most of the people are using every day, and it's powered by modern NLP. It's
Yeah.
powered by transformer, but it's not, yeah, it's not as kind of like, yeah, maybe the word is yeah, groundbreaking in terms of like experience changes as you could have expected, right? I think one of the challenges of NLP is that because language has been so much of a human topic
Hmm.
for so long, in a way it carries all these kind of like association with AI, right?
Hmm.
And kind of like AGI, and kind of like almost like this machine intelligence. And obviously, if you look at all the sci-fi with her, you associate that a little bit with NLP, and that's kind of like what you could have expected from NLP. And the reality has been more kind of like productivity improvements behind the scene that you don't really feel or see that much as a user. It's true.
Are you optimistic about chat interfaces?
I am. I think what most of us got wrong, and I mean, we started by building an AI friend, or like a fun conversational AI with Hugging Face. When we started Hugging Face, as I was saying, we were obsessed with NLP, and we were like, okay, what's the most challenging problem today? Open domain conversational AI, building this kind of like AI that can chat about everything, about the last sports game, about your last kind of like relationship, and really talk about everything. And we're like, okay, that's the most difficult thing. We're going to do that, and it didn't work out. So I think what we got wrong, and what most people are getting wrong is probably like the timing,
Hmm.
in a way, in the sense that conversation, and especially like open domain conversation, the way we're doing it now, is extremely hard. It's almost kind of like the ultimate NLP task, because you need to be able to do so many NLP tasks together at the same time, ranking them. I need to be able, when you're talking to me, to extract information, to understand, classify your intent, classify the meaning of your sentence, understand the emotion of it, right? If your tone is changing, then, it means different things. So I think we're going to get to better conversational AI ultimately. I don't know if it's in 5 years, if it's in 10 years, if it's longer, but I think we're gonna get there. It's already solving some kind of like more vertical problems with sometimes customer support chatbots. I
Mhm.
think Raza in the open source community is doing a really great job with that. So I think yeah, we won't get tomorrow to the AI who you can chat with about everything, kind of like what we started Hugging Face with.
Mhm.
But ultimately, I think we'll get there, and that's when, in terms of like user experience, it's going to, you're gonna realize it's different at that time, but it's probably going to take much more time than what we are expecting.
Cool. Well, we always end with two questions, so I'd love to get those in the last couple of minutes we have. We always ask, what's an underrated topic in machine learning, or maybe in your case, what's an underrated topic in NLP, like something that you might work on if you didn't have a day job?
That's a good question. I mean, something that I've been super excited about in the past few weeks is the field of speech.
Mhm.
So like speech to text, text to speech, because I feel like it's been kind of like a little bit like NLP like a few years ago. It's been kind of like relegated as some sort of kind of like a little bit boring field with not so many like people working in it. And I feel like thanks to a couple of like research teams, especially the team of Alexis Kono at FAIR with Wave 2 Vec, you're starting to see new advances, actually leveraging transformer models that are bringing kind of like new capabilities. So I'm pretty excited about it. I think there's going to be some sort of a resurgence of it, and kind of like a leapfrog in terms of quality, not only in English, but what's interesting is that it's also in other languages. We hosted a few weeks ago a community sprint at Hugging Face with over 300 participants who contributed models, speech to text, for almost 100 low resource languages, and so it's been pretty cool to see like the response of the community. So I think there's going to be cool things happening in the coming months in speech,
Mhm.
which is going to unlock like new use cases, because if you think that you can combine speech with NLP, you can start to do really cool stuff. We were talking about, what if like the product is built today, if Zoom was built today with like good speech to text and NLP, you could do pretty cool stuff too. When I'm seeing something like cheery, there should be like automatic clapping, because otherwise with everyone kind of like muting, that's the problem with the current Zooms, is that with everyone like muted, when
Mhm.
I say something to cheer, like I'm the only one cheering.
Mm.
Or when you say hoorah, there should be kind of like emoji showers of like celebratory emojis or things like that. So yeah, I'm excited for speech. If you haven't checked the field lately, you should definitely check it. There are cool things happening.
Very cool. And the final question, and I feel like you're in a unique place to see this, is, what's the hardest part, or what's some unexpected challenges in just getting a model from kind of thinking about it to deploy it into production? And I guess you have a unique point of view here, where you have a platform that makes this super easy. Are
Yeah.
there still challenges when folks use your stuff? Is there more to do, or does it work out of the box?
There are still a lot of human challenges to it, I think, in the sense that machine learning model is doing different things in a different way than traditional software engineering, and for a lot of companies it's really hard to make the transition. For example, the lack of explainability, the fact that it's harder to predict the outcomes of
Mhm.
these models, and kind of like tweak them in a way is still really hard to understand and adopt for people who've like spent a career in software engineering, when you can really kind of like define the outcome that you want to get. So I think from what I'm seeing, a lot of the time, like the human and kind of like understanding of machine learning part is the most difficult thing, more than kind of like the technical aspect to it. On the technical part, I mean, we've been excited to bring on kind of like larger and larger models, which are still kind of like difficult to run in production. So we've been working a lot with the cloud providers. We announced a strategic partnership with AWS not so long ago, but we're also working heavily with Google Cloud, Azure, and other cloud providers. But yeah, bringing this kind of like large language models in production, especially at scale, it requires a little bit of skills and require some work. You can get there. Like I think Coinbase has a good article and a good blog post on how they kind of like use one of our, I think it was distilled bird from transformers, on over a billion inferences an hour, I think, if I'm not mistaken.
Wow.
But it's still a challenge and still requires a lot of like infrastructure work to it.
Awesome. Well, thanks for your time. It was a real pleasure to talk to you.
Thanks, Lucas.
Thanks for listening to another episode of Gradient Descent. Doing these interviews are a lot of fun, and it's especially fun for me when I can actually hear from the people that are listening to these episodes. So if you wouldn't mind leaving a comment and telling me what you think, or starting a conversation, that would make me inspired to do more of these episodes. And also, if you wouldn't mind liking and subscribing, I'd appreciate that a lot.